You just write you in the chat box. Hi guys, how are you all? Hi everyone, am I audible? Am I visible to all of you? How are you doing, guys? If you are able to see me, if you are able to hear me, just make some noise in the chat box. Hi Sanjay, hi Praniti, Anmol, Radhika, Barbie, CL, Hap. Okay, Santara is here. Hi Santara, how are you? Okay, we have Nikki, Captain Wizard, Bandaru. Okay, Iron Man is here. Very good. Hi Iron Man, how are you? Where are your Avengers? Surajit, Captain Wizard, Soumya, Uma, Shravya, Sakshi, Sarag, Sachin, Santara, Rishabh, Jasmita, Mukund, Priyanshu, Sanjay, Sachin, Iron Man, Sasanka, Rishikesh, Sudama is here, Sachin is here. Very nice, guys. Very nice. Good to see you all. I hope all of you are doing fine. Okay, very nice, Tanuja. That's good. That's good. Cool, guys. How are you all? I hope all of you are doing fine, and I'm back with another session for my students who are JEE 2022 aspirants who are moving from 10th to 11th standard. Okay. So, guys, we have been meeting since the month of April. We have covered a good amount of syllabus already. Okay. We started our journey with units and dimensions. We talked about vectors, we talked about calculus, motion in one dimension, motion in two dimensions, projectile motion, laws of motion, recently work, energy and power, and now we are moving to new chapter called as horizontal circular motion, or rather in general circular motion. Okay, so a lot of chapters have already been done. I will tell you towards the end of the session how can you cover up the topics that if you have missed any of those. Okay, so let's start the session, guys, and let me start off with my introduction. For those who are not aware about me, do not know me, or are new on the channel, guys, this is me, your Suri Sir, and I'm an alumnus of IIT Bombay. And on this channel, I'm known as Mogambo. Why am I called Mogambo? Is because when you will crack this examination of JEE, Mogambo khush hoga. Okay. Yes, this is a new lesson, new chapter, everyone. And for those who are new, they might want to know the daily schedule that we follow for JEE 2022. That means 11th standard students. So every day at 7 p.m. we meet for theory discussion over here, like this one at this point of time, and 8 p.m. on certain days we meet for MCQs discussion. Okay, and for MCQs we will be meeting me on Tuesday at 8 p.m. You will meet Friday Love Sir for chemistry and Arvind Sir on Saturday for mathematics. Okay, so these are your teachers on Vedantu's JEE channel. Right now you're with me, I'm teaching you all physics. Okay, similarly Love Sir, as I said, is your chemistry teacher, and Arvind Sir is your maths teacher. Okay, so guys, let's start. And if you are new on the channel, definitely you need to know when do your teachers come live. For that, I want you people to subscribe to the channel right now and press that bell icon as well, so that whenever your Mogambo is coming live, you get the notification. Okay, people, let's start the session. I hope all of you are ready, and the discussion is about horizontal circular motion, next time about the vertical circular motion. So guys, first of all, any circular motion is fundamentally a 2D motion. Why it is a 2D motion? Have a look at this body which is moving. So when it is moving in a circle, it is covering a path, a trajectory in a circle which is basically lying in a plane. And whenever a body moves in a plane, we know this from our understanding of projectile motion as well, that its x and y coordinate, both the coordinates are changing with time, and that is why we are calling this motion to be a 2D motion. Okay, so what does it say? A motion of a particle along a circular path in a horizontal plane. Yes, definitely horizontal plane is what right now is important, because gravity is going to act perpendicular to the circle, That means what? If a body is moving, it is moving in a circle like this. So gravity is acting vertically downward. So this will be a horizontal circular motion. Now what is to be noticed here, guys, that when this body is moving in a circle, there is a force which will always and always act towards the center of the body. We'll be speaking about it. I'm sure you have heard about that as well. We'll come to that part in the dynamics today, but we'll obviously start off with the kinematics part and the quantities which are related. So we know this from our 2D motion understanding that if we trace the path of the body is moving. The body is moving in a circle, which is the trajectory of the body. At any point, if you go and you draw a tangent, then this tangent is going to represent the velocity of the body at that particular point. So wherever you want the body's velocity, all you have to do is go on the trajectory, go on the path, draw a tangent wherever the body is actually appearing to be moving, and the tangent will give you the direction of the velocity. And there is a force which is always acting towards the center of the body. Its magnitude is constant or variable. I'm going to get it clarified in some time from now. Okay. Awesome, guys. Awesome. So let's understand the quantities which are related and very important to understand circular motion. Obviously, the direction of the body is continuously changing when it is moving. You can see that the direction of velocity was changing here when the body was moving. So you cannot talk in terms of linear displacement, linear velocity, linear acceleration anymore. So you will have to define its angular quantities. So we are going to define different quantities called as angular quantities here. And now the displacement that will be measured when the body is moving in a circle, it will be measured when the body is moving. There will be only two sense of motions possible. One will be clockwise, other will be anti-clockwise. And in both the cases, the body will have a circular motion being performed. So when your body is moving like this, say if it moves from point P to point Q in a time interval t, and it traces an angle theta at the center of the circle. The arc which is covered by the body, the radius vector is tracing an angle theta. Then we define this theta as the angular displacement. That means the angle by which the body's radius vector is rotating. Means what? If this is point P and you trace its location at point P, that basically is giving you a radius vector, right, guys? So this radius vector is moving along with the body is moving on the circular path. So the angle that is traced out by this radius vector is what we call as the angular displacement. And we know how angle is calculated is nothing but the arc length upon the radius. So it is nothing in terms of mathematics, it is still the angle, but in physics you will be calling it angular displacement. Okay, its unit is going to be radians. Okay, for all those who do not know this, you should know that the angular SI unit is radian. So the conversion between degrees and radians is pi radian is going to be equal to 180 degrees. Remember this, guys, which means what? If we are talking about 180 degree angle, that will be pi in radians. If you are talking about 90 degrees, it will be pi by 2 radians. If you are talking about 360 degrees, it will be 2 pi radian. I hope you guys are following. If you are talking about 45 degree, it's pi by 4 radian. If you are talking about 60 degree, it will be pi by 3 radian, and so on and so forth. So radians is going to be the SI unit of angle measurement. Okay, perfect, Pranati. Very nice, guys, very nice. Keep it up, keep it up. So this is angular displacement, the angle that is traced out by the radius vector when the body is moving in the circular path. Now how fast or how slow this angle is being measured is what will be related or will be defined as angular velocity, represented by this symbol. This symbol is pronounced as omega. Okay, that angle was represented by a symbol called as theta, and angular velocity will be represented by the symbol that is omega, and it is nothing but the rate at which angle is traced, how fast or how slow that angle is being covered, or you can say that the time rate at which angular displacement is changing when the body is moving. Then we will say that the rate at which that is happening is called as the angular velocity, and SI unit is going to be radians per second. Okay, perfect, very good, guys, very good, awesome, cool. Now what is important here is to talk about the direction of angular velocity. So if you want to find out the directions here, the direction will be found by using right hand thumb rule. Right hand thumb rule. Same for angular displacement as well, by the way. So if your body right now is moving in a clockwise or anti-clockwise path, as per the diagram, if you look at this, the body is found to be moving from point P to Q, which tells me it's an anti-clockwise sense of rotation. So if you will curl your right hand along that sense, the thumb will be pointing towards you, which is basically a vector coming out. And that is what right now this vector is telling you. This dot is telling you that the angular velocity is a vector that is coming out. Okay. So apart from the vectors that we usually represent, for a vector that is coming out, we will represent it by a dot. If there will be a vector which will be going in, you will represent it by a cross. Okay, perfect. And same thing will be applicable for your angular displacement vector also. Means what? Right hand thumb rule will be applicable to find out the direction of theta as well as omega. Okay, awesome guys. Now apart from this, when we speak about the relation or the direction in general, so this is how basically I was talking about. This is the sense in which if you rotate your right hand fingers, then the thumb is pointing upward. If it will be sense of rotation being clockwise, then thumb will point downward. Okay guys. Now the relation between linear velocity of the body and the angular velocity of circular path. So how we are going to relate that? First of all, say when a body is moving at a given situation or in a given circular path. So let's assume that your body is moving from point P to point Q. Okay. Now in this path, what is happening? The body is covering a good amount of displacement, right? If I divide this displacement into small displacements like this and start calling each and every displacement at ds, which is covered in a small time dt, such that the ds displacement is almost a straight line path. So we can say that the velocity or the speed will be ds by dt. And now we can write down ds because we define the angle. So this angle is a very small angle traced as d theta. So we can say that d theta will be equal to ds by r. So ds can be written as r d theta. The same definition, angle is arc upon radius. So arc can be written as radius into angle. Now what I have is the radius magnitude multiplied by d theta by dt. And d theta by dt is nothing but your angular velocity, the rate at which angle is changing. So we get a very important relation here, which is omega, v and r and omega related to each other. Comes out to be v equal to r omega. And if you ask me the direction, then vectorially v is written as omega cross r. Okay guys. So here in this diagram, if I have to tell you, if this is where the body's velocity vector is heading to, okay, and perpendicular to the plane is your omega vector, then this is your r vector, then omega cross r, if you rotate, you will get the direction of velocity vector. Similarly, at this point, this is the direction of velocity that is coming towards you. This is the direction of omega vector, and this will be the direction of r vector. So omega cross r by right hand thumb rule still gives a vector that is coming towards you. So remember, v will be magnitude wise omega r or r omega, and vectorially it will be omega cross r. Remember that. Okay guys, v is not the resultant velocity, v is the linear velocity of the body at a given instant. Okay, remember the relation. Now after angular displacement and angular velocity, how about the rate at which angular velocity is changing? So this will be found as alpha. Okay, so angular acceleration will be defined as the rate at which your angular velocity is changing. Okay, units will be radians per second square. Now important part is the direction of alpha and omega will not always be same. If your angular velocity is increasing, then alpha and omega have the same direction. But if your angular velocity is decreasing, if omega is decreasing, then your angular velocity and angular acceleration will be in the opposite direction. Why so? Because alpha is omega final minus omega initial divided by change in time, So if omega will decrease, then this value will come out to be negative, which will tell you that the direction is just the opposite. Okay, guys, remember everything is going in sync with the linear motion. It is just that here only possibility is understood in terms of angular physical quantities. There, when we used to talk about motion in 1D, body had only two choices to move, forward or backward. Here a body has only two choices to move, that is clockwise and anti-clockwise. So here the linear quantity which used to be displacement has become angular displacement. What used to be velocity has become angular velocity. What used to be acceleration or linear acceleration has become angular acceleration over here. Okay. Perfect. Yes, to differentiate omega, you will get the value of angular acceleration. Okay, guys. Now, depending upon whether omega is constant or not, you have two types of circular motion. First is uniform circular motion, in short called as UCM. So if your omega is constant, then definitely alpha will be 0. And the other possibility is non-uniform circular motion, where your omega is not a constant, so definitely your angular acceleration will not be 0. Okay, guys. Now, if you try to remember, this was uniform motion, this was non-uniform motion. That's what we are talking about. So if I speak about this part here, if omega is constant, then displacement will be equal to velocity into time. This will be your equation that will be valid. And if we speak about this case, then you will have three equations of motion if your alpha is constant. Okay. If your alpha is constant, then you will have three equations of motion, which are basically written over here, just to see it as a correlation with your linear counterparts. So if alpha is constant, remember it's a big if alpha is constant, if angular velocity is changing at a constant rate, then you will have similar equations as we used to see in case of linear motion, right? So what you see here, v equal to u plus at becomes omega equal to omega naught plus alpha t. S is equal to ut plus half at square becomes theta equal to omega naught t plus half alpha t square, and v square equal to u square plus 2as becomes omega square equal to omega naught square plus 2 alpha theta. What does it mean? That omega naught is initial angular velocity, omega is final angular velocity, you have theta as angular displacement, and alpha as angular acceleration, and obviously t is time. Cool, guys? Okay, Shirish under root 5 RG will be explained in the vertical circular motion. This is horizontal circular motion. Okay. Yep. Thank you, Nishit. Now, guys, when we speak about accelerations, there are two types of accelerations that we are going to study here. The first one is called as centripetal or radial acceleration. So this acceleration is called as the necessary acceleration for a circular motion. This is called necessary acceleration for circular motion. And why it is necessary is because this will always make sure that the body is moving in a circular path, and because it acts towards the center, that's why it's called centripetal, or along the radial direction, that's why it's called radial acceleration. Okay, this comes into existence because of change in direction of velocity. Because of change in direction of velocity. And we are talking about linear acceleration. These are linear accelerations. Okay. So if you have your body's velocity changing continuously like this, which is inevitable in a circular motion. In a circular motion, the body's velocity has to change at least in terms of direction. Even if the magnitude is not changing, the direction has to change. So you can see that velocity vector, even if it is constant in terms of magnitude, if speed is constant, the direction is always changing. So if you connect the force which is responsible for this to happen is basically the force which will make the body have this acceleration called as centripetal or radial acceleration. It is given as v square by r or omega square r. Please remember this formula. This is a very, very important formula for us. Okay guys, angular acceleration was for angular quantity. This is linear acceleration which is acting towards the center, okay, called as centripetal or radial acceleration, given as omega square r or v square by r, whichever is given to you, you will be calculating accordingly. Now, the other acceleration, which is because of the change in magnitude, look at this, this is the change in direction, because of change of, oh my god, I have written it twice, because of change in direction of velocity. This acceleration comes because of change in direction of velocity. The other acceleration, which is coming as tangential acceleration, you can look at the direction of that acceleration is tangential. This comes into existence because of change in magnitude, okay, of velocity. When your velocity's magnitude will change, which will not always happen in a circular motion. If that happens, then you will have tangential acceleration, and for that to happen, a tangential force must act. That's why tangential acceleration is dv by dt, which is written as r into alpha, because it is dv by dt, which is d2s by dt square. S can be written as r theta. R is not changing, only theta is changing in terms of magnitude. So d2 theta by d theta square, which is alpha. So tangential acceleration and alpha are related as at equal to r alpha, just as you had v equal to r omega. You can get from here also. If you write dv by dt, then dv by dt will give you r d omega by dt, and d omega by dt is alpha. Okay, awesome, perfect. Yes, Sonia, a equal to r alpha. Now, if we look at them both simultaneously, so by any chance, if both of them are simultaneously present, that means what? Tangential acceleration is also there. Then the direction of radial acceleration is towards the center and tangential is along the tangent direction. So both of them are basically perpendicular to each other. So this is basically their resultant acceleration. The radial acceleration we already know, v square by r. Tangential we already know, dv by dt. So the resultant acceleration or the net acceleration of the body which is moving in the circular path, when both the accelerations are non-zero, is given as under root of, or you can say the resultant of at and ar. Okay guys, so you will be able to find out the net acceleration depending upon whether tangential acceleration is 0 or non-zero. Okay guys, now what exactly these accelerations, or why exactly they are coming into picture? So centripetal acceleration is the result of centripetal force. Means what? I can say that your centripetal or radial force is nothing but mass into centripetal acceleration. So simply your radial force or centripetal force comes out to be m omega square into r, or it can also be written as m v square by r. This is the formula for your centripetal force. This is centripetal force, or you can also call it radial force. Okay, direction is towards the center. Always remember that. Okay guys, similarly, the force which is responsible for tangential acceleration, ft, is basically mass into tangential acceleration, and this is very simple. It is m into dv by dt, or at is equal to alpha r, so you can also write it as m into alpha into r. So this is your tangential acceleration. Direction is always tangent. Okay, very good guys, very good. So let's see some examples to understand the topics or the concepts that we have covered today. Okay, so guys, first question, it says that which of the following statements is false for a particle moving in a circle with a constant angular speed. Okay, that means its alpha is 0 because its omega is constant. So it says that the velocity vector is tangent to the circle. This looks right. The acceleration vector is tangent to the circle. Well guys, acceleration vector will be tangent to the circle if you have velocity changing. So looks like this is going to be our answer, but let's see other options as well. The acceleration vector points to the center of the circle. That is definitely the case because your tangential acceleration is going to be 0, because tangential acceleration a is equal to alpha r. That will also be equal to 0. And the velocity and accelerations are perpendicular to each other because the only acceleration which is present right now is radial acceleration, and this is velocity, so they are perpendicular, which means answer is option B. Perfect. Deepak, Hiyansh, Tech 1000, Ritika, Rupesh, Jayasmita, Sakshi, Pranati, Dhan, Mishra, Suthir. Very nice, guys. Very nice. Sonia. Very good, guys. Very good. Let's solve a numerical. This question says that we have a body which is whirled in a horizontal circle of radius 20 centimeter. It has angular velocity of 10 radians per second. So what do you think will be the linear velocity at any point? So V will be equal to omega into R. Omega ka value is given to us as 10 radians per second, and you will have to put the value of R in terms of meters. So this is 20 by 100 because we have converted it into meters. So V comes out to be 2 meters per second. Answer again comes out to be option B. Very good, guys. Very good. Remember, this is centimeters, so you will have to convert it into meters. Okay, cool. How about this one, guys? A particle is moving along a circular path of radius 2 meters with a uniform speed of 5 meters per second. What will be the change in the velocity when the particle completes half of the revolution? So guys, if you look at this, V initial is 5 j cap and V final is minus 5 j cap. So if we want to find out the change in velocity, it has to be V final minus V initial. That is minus 5 j cap and minus of 5 j cap. That comes out to be minus 10 j cap, and the magnitude looks like it's going to be 10 meters per second. Okay. So the magnitude of delta V vector, change in velocity magnitude, comes out to be 10 meters per second. Okay. Very good, guys. Very good. Keep it up. Awesome. Very good, guys. Next question. Now this is a very good question. Question says that two particles of mass capital M and small m moving in a circle of radius r and small r, if their time periods are same, so their time periods are same, what will be the ratio of their linear velocity? So guys, when a body is moving in a circle, and that too, say assuming that it's with a constant velocity or constant speed, say the speed is v and the radius is r. So you know that time period is basically the total distance divided by the speed. That's the formula that you will use. So the total distance covered in a circle is going to be 2 pi r and speed is going to be v. And this is given to us as same for both the particles. So that means capital R by V1 will be equal to small r by V2. Question is asking us to calculate the value of V1 by V2. So V1 by V2 comes out to be capital R by small r, which means answer is option C. Very good, Sugam. Perfect. Bhanu, Rupesh, that's the answer. Yes. Deepak, Dhan Gamer, Sonia. Yes, guys. Yes. Awesome. Very nice, guys. Very nice. Keep it up. Okay, now this one from non-uniformly accelerated motion. It says that the angular displacement is given by this equation. If theta is in radians, t is in time, then the angular velocity after 2 seconds from start will be what? So omega will be found as d theta by dt, rate of change of displacement. So that comes out to be 2 into 3t square plus 0, or simply 6t square. I'll put the value of t as 2. So that comes out to be 6 4s are 24 radians per second. I get the answer as option C. Have you? Okay. What happened, random bro? What happened, Barbie? I have been solving the questions. Random bro has a doubt that which book to follow. I have always said this in my classes. It's not about the books that you follow, guys. It's about, are you solving the books or not? It's not just about bringing the book, keeping it below your pillow and sleeping over it, because there is no data which will download from your book to your head. For cracking any examination, just just buy any good book that you might have heard about. That could be H.C. Verma, D.C. Pandey, Arihant, or B.M. Sharma. Any book, guys, any book. I'm not even endorsing any of those books. You can go for any book which you have heard from your seniors, from your friends, from your elder siblings. Pick any book. More importantly is to solve the book. If you are not solving, nothing is going to work in your direction. You have to solve the book, then come to the conclusion which book you are able to solve, which book you are able to understand better. So don't be worried about the number of books or the thickness of the book. Okay. Cool. Don't worry, guys, I'm coming live tomorrow at 3 o'clock as well, where we are only going to discuss these things. So telling you all, tomorrow at 3 o'clock in the afternoon, I'm coming live. I will not teach, I will just clear all these doubts of the students, which book to solve, about JEE 2020, whether it is happening, not happening, what should I do if it is going to get postponed, if it is not going to get postponed. And for people who are moving from 10th to 11th, 11th to 12th, whichever thought you have, guys, come tomorrow live at 3 o'clock on this channel. I'm coming not to teach, just to talk to you guys. Remember that, okay? For the meanwhile, next question. The angular speed of a motor increases from 600 RPM to 1200 RPM. Now, what exactly is RPM? RPM is rotations or revolutions per minute. Okay, so if you have 1 RPM, that simply means 1 rotation in 1 minute, which means what? There are total 2 pi radians being covered in 60 seconds. So you will say 1 RPM is 2 pi by 60 radians per second. So if I have 600 RPM, I will say it is 600 into pi by 2 pi by 60 radians per second. This cancels 10 times, that means it is 20 pi radians per second. And similarly, 1200 RPM will be 40 pi radians per second. So 20 pi and 40 pi radians per second, guys. Clear? 600 RPM is 20 pi radians per second, and 1200 RPM is 40 pi radians per second. So what is the angular acceleration? Alpha is change in angular velocity upon change in time, and that is 40 pi minus 20 pi happening in 10 seconds. That is 20 pi by 10, or simply 2 pi radians per second square is the value of angular acceleration. Very nice, guys, very nice. Answer comes out to be option D. Okay. This one, guys. This says that a car is moving with a speed of 20 meters per second on a circular path of radius 100 meters. If its speed is increasing at a rate of 3 meters per second, that means dv by dt, which is nothing but tangential acceleration, is given as 3 meters per second square, right? So tangential acceleration is there. And if I calculate the radial acceleration, which is v square by r, then that is going to be 20 into 20 divided by 100. That comes out to be 4 meters per second square. Which means what, guys? In a circular motion, you have your radial acceleration and you have your tangential acceleration. You have to find out the resultant acceleration A. So A is going to be AT square plus AR square in under root, which is 3 square plus 4 square in under root, and you know that the value will come out to be 5 meters per second square. Okay, guys? Very good. Awesome. Perfect, guys. Okay, always check the options. You will be able to see whether you have to work with angular quantities or linear quantities. Accordingly, you will get that. Okay, now your homework question. says that at a particular instant, a particle is moving at a speed of 10 meters per second on a circular path of radius 100 meters. Its speed is increasing at a rate of 1 meter per second square. So tangential acceleration is 1 meter per second square, and radial is not known. You have to find that by v square by r again. So what is the acceleration of the particle? Again, you have to solve for at square plus ar square in under root. That's what you have to solve. Okay. Cool. Now, how to cover up topics which I have already covered, which I have already taught. So for that, all you have to do is go on the channel playlist, and on channel playlist, which playlist you have to look for? You have to look for JEEt Lo 2022, and that is the playlist that you want to use to cover up all the topics that you have missed, which I have done already. Okay. Also guys, if you are interested, or your family members, there is a quiz which happens every day on Vedantu's platform. For that, you need to have the latest version of app which you can download from the Play Store or the App Store of your mobile phone. Okay. Remember, there is a lot of prize money at stake as well as Paytm cashback. Okay guys. Also for my JEE 2020 students, or 2021 and 22 as well, guys, if you are interested, we have a Vedantu Pro subscription, which is basically learning on Vedantu's platform. For that, obviously, you will have to follow this link, which is available in the description box. When you click over there, you will have to select your class that you are moving on to. What will you get in this Vedantu Pro subscription? When you are learning on Vedantu's platform, not just on YouTube, you will get live interactive session on our platform, assignments and study material, and test series and your own analysis. Let me show you how exactly it looks like. So this is how the Vedantu's own platform looks like. This is where the teacher is visible to you. This is where you can chat and ask your doubts as well. And this is where the concept explanation is being done by your master teachers. Okay. So if you are interested in joining Vedantu Pro, there are multiple possibilities like monthly, quarterly, half-yearly or annual subscription. Look at this. If you are moving to a longer subscription, definitely the per month cost is going to get lesser and lesser. And if you enroll right now by clicking on this link, which is available in the description, you can avail additional 15% discount. For that, all you have to do is use this coupon code SMPRO, and you will get an additional of 15% discount on any of the subscription. Okay, these subscriptions that you are looking at. Okay guys, cool. I hope it's understandable to everyone, so do take the advantage. And if you want, you can also be a part of our Telegram channel where we share assignment solutions. You will find the assignments in the description box of this video. Solutions are being shared on the Telegram group. Study material and daily updates are also being shared over there. For that, you have to follow the link. Okay guys, and let me tell you that tomorrow, what is tomorrow? Tomorrow I think is the date, that is 30th of June. Yeah, so tomorrow is 30th of June at 3 p.m. I will be live to talk, just to talk. Okay, so do come, bring your doubts, not subject related doubts, those who are still worried which book to study, which of the study materials are good, should I prepare for engineering or not, should I prepare for medical or not, should I go for science or not, if I'm a 2020 student, should I start with the topics which are still left, which I'm not very good at, is JEE examination getting postponed or not. So tomorrow, yes, tomorrow 30th June 3 p.m. note this down time. Okay, tomorrow I'm coming live to talk to all of you guys. Okay, so guys, see you all tomorrow. Okay, 12th standard students, 8 o'clock I'm coming back again today only to discuss the MCQs of current electricity. Okay, so guys, if you enjoyed studying with me in this video, do hit that like button, give me a thumbs up over here, and share with your friends. Let them also see how things are going on here, and subscribe to the channel if you have not. Along with that, press the bell icon so that you get the notification whenever your Mogambo comes live to see you all. Okay, cool guys, so see you all again at 8 o'clock. If you are interested, come for that session also. Okay, right now it is 7:40, so in 20 minutes I'll see you again back on this channel. Okay, see you all, take care, bye bye.